press the bell icon on the YouTube app and never miss another update.
Okay, children, we have been discussing physical optics. Meanwhile, we have done with few sessions. So, where few topics we have come across in the chapter, right from the beginning of theories of light, and then like Huygens explanation for laws of reflection, refraction. After that, superposition of two waves, how to find the resultant wave equation we have studied. After that, we started with interference. In that, we have studied about the conditions for constructive and destructive interference, both in terms of phase difference and path difference. So, if you just recall them, for constructive interference, phase difference will be equals to 2 n pi, path difference should be equals to n lambda we have studied. Also, for destructive interference in terms of phase difference, we have written 2n minus 1 into pi, and in terms of path difference, we have written 2n minus 1 into lambda by 2. So, I have winded up my session in the previous class, right. So, up to that part, and one more some relations among amplitude and intensity, how resultant intensity it is going to be and resultant amplitude. Based on that, we have studied some relations, some problems to be solved on them. We need to discuss some problems related to that even. For problems, one more session I am going to take. After discussion of that relation of intensity and amplitude, various parameters and relations among them, we have come across Young's double slit experiment. During that course of discussion, right, I mentioned the importance of coherency. So, what do you mean by coherent sources? Two individual point sources will never act as coherent sources, we have studied. So, for that, what Young has considered the virtual sources, means two sources or two virtual sources which are coming from a point source itself. From the same source, two sources are going to be originated, right. Origin of those two virtual sources will be of what? Single source, hence they will be having the same frequency, and that too amplitude division, wavefront division concept we have taken, we have studied them, and how the interference pattern is going to be formed on the screen, we have discussed in the previous session. So, in continuation to that, we will get one important derivation here, expression for fringe width in case of Young's double slit experiment. We have to obtain expression for fringe width, expression for 5 marks, an important question mark, expression for fringe width. Briefly, I have introduced a term called fringes in the previous session. So, what actually the fringes are, bright fringe, dark fringe, like that, we spoke about that. And I told you even that in case of constructive interference on the screen, whichever it is taken, right, in case of Young's double slit experiment, wherever the constructive interference has been taken place, right, which type of fringe has been formed there? Bright fringe has been formed. And at the same time, if destructive interference has been taken place, then it is dark fringe is going to be formed at that point, we have studied. So, more in depth about that we have to study, more about the intensity pattern on the screen, how we are going to have in case of Young's double slit experiment. And that too I have mentioned, in case of Young's double slit experiment, remember interference phenomena will take place only if the light from the coherent sources, no doubt, that too from that coherent sources, primary wavefronts when they are going to superpose. Only due to the superposition of the primary wavefronts we are going to have the interference phenomena. If it is not primary, then interference phenomena will never take place. Keep this point in mind. Theoretically, if they ask anything on that, should be able to answer for it. Okay, meanwhile, like one more point we have studied, whenever the two waves from two coherent sources, right, when they are going to superpose, like constructively, if it has to be, phase difference should be pi, 0, 2 pi, 4 pi and so on we have studied, and also for destructive interference pi, 3 pi, 5 pi we have studied. and also exactly at the center of the screen which type of, what exactly is going to be formed at the center of the screen? Central bright fringe is going to be formed, we have studied. On either side of central maxima or central bright, we are going to have consecutive dark and bright fringes. Exactly at the center bright fringe is going to be formed, and on the either side of that central bright we are going to have consecutive bright and dark. First dark, next first bright, second dark, second bright, third dark, third bright, and so on either side of that, above the central fringe as well as below the central fringe also the same phenomena it is going to be formed, we have studied. So now we need to illustrate that theoretically we need to obtain certain relations to solve certain problems, right? How the intensity pattern, how it is, how the amplitudes of that final resultant, or how the intensities of those all the bright fringes, whether it will increase or decrease as you move away from the central fringe, how that pattern it is going to be, we have to analyze that. So meanwhile in that course we have to discuss about what, or we need to derive an expression for fringe width. I will explain what do you mean by fringe width, we will see. For that I am going to consider the diagram which we have drawn earlier, right? So what is that? There is a cardboard they have taken. This is what a cardboard. Let me say, two holes they made for it. This is the center of somewhere here you are going to have some point source. You know, a point source is going to produce spherical wavefronts like this. So one of the source, right? One of the wavefront is getting divided over there, and from that, see, somewhere at larger distance from these slits, we are having a screen. This is what the screen is, and this is the center of the screen, keep it in mind. And terminology also you remember, they are important. Distance from these slits to the screen, we have taken it as cap letter D. What is capital D? Distance between slits and the screen. Important derivation, keep it in mind. And now let me rub this, not required. Okay, this was the two slits, small slits there, and this was the source, and the distance between these two slits we have taken it as small d. What is small d in our derivation? Distance between two slits. Now for example, light ray from this particular point and from here, right, two slits are S1 and S2 I am going to call. Two slits are what? S1 and S2. One of the light ray or light wave from this particular point and another light from the other slit S2. So let me consider this is what one of the wave, and this is another wave which is traveling from S2 to the point P. Let us say this is what one of the point P we are going to consider. We are going to analyze the interference pattern that has been taken place due to the superposition of two waves coming from these two coherent sources on the screen P. At this particular point on the screen, analysis of these interference phenomena, how actually interference phenomena taking place at this point, and then we will generalize that based on what exactly we are going to consider here. Now let me say this distance P from the center, it is at a distance of y. How much distance it is at a distance of y? Point P is at a distance of how much? Y from the center C. Okay, and again I am going to draw one more line from this center point to this particular point P, and let us say this is going to subtend an angle theta at this point. This one angle between the line joining this point, whatever it may be, something from the center, you know, like O or something we will call, from O to P and O to C, right? What is the angle it has been made? Theta I have taken, and I am going to draw one normal from this point source S1, see, to this point. This is some S2, I am going to call this, and this is perpendicular, remember, foot of the perpendicular, I am going to call it as some N. Remember, I am going to draw a perpendicular line from S1 to the line joining this S2, foot of the perpendicular it is. Foot of the perpendicular means what? These two are perpendicular to each other. Now, if you observe which is bigger here, S1P is more or S2P is more? Obviously, from the geometry you can say that the distance S2P is more than the distance S1P. What does it mean? Means I will just roughly draw here, see, these two are the 2 points, means I have drawn the ray diagram like this, means what? A wave starting from this source S1, it is going to travel like this, and this is another wave, right, traveling over there like this. If you observe, right, somewhere at this point, let me draw here, let's say, from here equal number of, if 10 waves are passed from here to here, even from here also 10 waves are passed, means what? These lengths are equal, S1P and I have named it as what? N, no? So NP and S1P are equal. If you observe one thing here, this distance from S1 to P and N to P are equal, these two lengths are equal. How about this distance what we are left out? This is S2N. Can you tell me what actually this S2N is? S2N has travelled this much amount of extra path. Extra path it has travelled. How much extra path it has travelled? What do you call that extra path travelled by one of the wave with respect to the other? That itself we should call it as what? Path difference. What do you call that one as? Path difference. Keep this point in mind. So in our relation, this S2N, I am going to call it as some delta X. What do you call that delta X as? Path difference between the two waves which are superposed to form certain intensity pattern on the screen. The two waves from these two slits S1 and S2, remember these two are already coherent sources we have defined. So the light waves from these two coherent sources will superpose to form certain interference pattern on the screen. And we have observed this is the extra path what the S2P has travelled in comparison to S1P. When you compare with S1P, right, S2P has travelled an extra path of how much? Delta X. I have called it as path difference between the two waves. And remember, by geometry, if this angle is theta and this angle also will be equals to theta, and remember this angle is theta and we have named this distance from here to here is what? Capital D, and this is y and this is small d, theta value we have written. If you observe and remember what are all the angles we are making, they are all within paraxel approximations. Paraxel, all the experimental values what they have calculated. In geometrical optics I have already studied what do you mean by paraxel approximations. Means the light rays which are very nearer, almost parallel to the principal axis. Very small angles when they are going to make with the principal axis, right? So that comes under paraxel approximation. And remember in case of paraxel, all the geometry what you have studied, ray optics, what are all you have studied, each and everything. You have derived the expression for focal length of the mirror, relation between focal length and radius of curvature of the mirror you have derived. There you have taken one of the light ray travelling from focus to the and certain equations wherever you have written. From that point where the light line is intersecting on the mirror to this principal axis when you drawn, you have taken that length as directly to the center of, to the pole you have taken the distance, meaning is this one. If a light ray travel like this, you have taken this length. So means this point you have taken it as what? Pole itself you have taken. How? By paraxel approximation. If you take for the larger distance, right? See, like larger angle if I am going to consider, small angle if I take, this is almost same, this is smaller angle, right? Then it is almost near the pole itself you are going to get. But if you take larger angle, it is not at the pole. Got the point? So angles which have been made very smaller with the principal axis, which they will come under paraxel approximations. So based on these paraxel approximations only, the entire geometrical optics what you have learnt has been run. I hope you have known that particular point. Entire geometrical optics is under the consideration of these paraxel approximations. Otherwise, if that paraxel approximations, if you are not going to take larger angle 90 degrees, if you are going to take, for example, a light ray is incidented on a mirror at 90 degrees angle or some 80 or 70 degrees angle if you take, so they will not work so easily for small lenses or small mirrors. Of course, they are going to work for the large angle of the or bigger geometry of these lenses or mirrors if you are going to take, they are going to work. Keep that point in mind. So under paraxel approximations, remember 2 points over there. Sin theta is almost equals to theta you are going to consider. Why? Because for smaller angles of theta, means under paraxel approximations what happens, the value of theta will be very less. The value of theta is very less in case of under paraxel approximation, means theta is almost nearer to the values of 0. What is the value of sin 0? Sin 0 if I take it will be 0, right? Sin 30 1 by 2 means between 0 and 30 degrees all the values lie in between 0 and 0.5, means sin theta is almost equals to theta if the values are very closer to 0. means little bit lesser. For 1 degree if I take sine 1 degree is almost equals to like in terms of radians if you write, whatever the value you are going to get, that value you are going to get. Sine 0.25 I am going to take, 0.25 you are going to mention. Radians in terms of radians if you are going to mention, right. So you have to convert the degree to radians and you have to take. So that's why under paradoxical approximations I can say sin theta is almost equals to theta and tan theta is almost equals to sin theta and it is almost equals to theta. This one paradoxical approximation you have to remember when you are studying with any kind physical optics or geometrical optics, whatever you are going to study. So under considering these paradoxical approximations only, we are going to have all the ray diagrams it might be, derivations it might be, all considerations which we have done with all the equation part whatever you have studied with, all by considering these paradoxical approximations. So I hope even while you have learnt with geometrical optics, so many points over there, you might have taken these assumptions over there. So even the same geometry I am going to reconsider here. So what is that? See, I am going to write for this angle theta here now. Tan theta equals to what? Is y divided by d. Here tan theta it will be equals to y by d. Keep it in mind. And also from this sin theta can be written as what? From this sin theta it will be equals to what? Sin theta will be equals to, sin theta it will be equals to, this is delta x. Remember this is perpendicular, foot of the perpendicular. Then obviously this side S1 S2 will become what? S1 S2 is going to become hypotenuse. What is the length of S1 S2? D, small d we have taken. So that's why sin d equals to, opposite is delta x divided by d. Opposite is delta x and hypotenuse is what? D. So I am going to reconsider. From this I can write path difference relation is what ma? From the diagram, path difference comma delta x it will be equals to d sin theta. Path difference delta x equals to d sin theta and tan theta value what we have written? Tan theta it will be equals to what? Y by d. Tan theta equals to y by d. So from this small approximation what we have written, in place of sin theta for paradoxical approximation, what you can write here? Sin theta is almost equals to theta is almost equals to tan theta I can replace. In the place of sin theta, I can replace with what? Tan theta. So if I write for the value, what you will get? Path difference delta x will be equals to, see small d I am going to rewrite, I am going to retain small d value. In place of sin theta, I am going to write y by d. So it will be d into y divided by d. So let this be as an equation number 1, or it might be, just have it as an equation number 1. See, this is what the expression for path difference we have written. Relation for path difference in terms of the given parameters. What are the given parameters? Slit width, distance from central bright or central fringe to the point where you need to find out the path difference. At this point, whichever the waves will, all the points which are reaching here, right, will have a path difference of how much they will ask? This much. Delta x equals to d into y by capital D. If you know the distance from central fringe to this point P, distance from central fringe to point P y, and distance between the slits and the screen capital D you are aware, distance between the two slits if you are aware, then the expression for path difference it is going to be written as means path difference for what exactly it is? Path difference for the waves which are reaching at this point. Waves from this source S1 and waves from this source S2. Okay. So the two waves which are reaching at this point means they are going to superpose, they are going to fall one or the other, and finally they will reach at point P. They are supposed to have a path difference equals to d into y by d. We have to generalize this formula even, not all the time they are going to give the values of y, right. So they will give what is the wavelength of light incidented. They will give, most of the time they will give for what? Wavelength of light incidented, how much it is they will give, lambda value they will give, and capital E value they will give, and small d value they are going to give it. So then how to write for the value of delta x? We know, let me say at this point a constructive interference has been taken place. Let at P nth bright fringe is going to be formed. What is going to be formed at P? I am going to say nth bright fringe. At P, nth bright fringe is going to be formed. Bright fringe is going to be formed. Nth bright fringe is formed. If I say nth bright fringe is formed here means we have already seen the condition for constructive interference. Bright fringe means I told you constructive interference will take place at that point. Which bright fringe it is? Nth bright fringe. Then what should be the value of delta x or path difference state? Then delta x equals to, what's the path difference formula we have written for constructive interference? 2n minus 1 into lambda by 2. See, path difference delta x equals to 2n minus 1 into lambda by 2. So this should be the path difference between the two waves which are superposing here to form the nth bright fringe. If I say if this point is of that, then we need to relate these two. But path difference from these two, what you can write, tell me now? From 1 and 2, from equations 1 and 2, what you can write me? Like d into, this is yn I will write, nth bright fringe, divided by capital D equals to, this is 2n minus 1 into lambda by 2. I can obtain the relation for distance of nth bright fringe from the central fringe. Implies yn it will be equals to what? You will get, tell me now? Yn equals to, for constructive interference path difference should be n lambda. This is not this. Okay. For constructive interference, right, what should be the value of path difference? N lambda, it's not 2n. For destructive means I can write, if it is the formula I have written, it is for destructive, but dark fringe it is going to be for delta x equals to n lambda, or d into yn by d it will be equals to what? N into lambda, or rewriting this formula again, yn it will be equals to what? N lambda capital E by small d. This is the formula you will get for this. What actually it is? Distance of, remember this formula, distance of nth bright fringe, distance of nth bright fringe from central fringe, remember, note down this value even, distance of nth bright fringe from the central fringe is how much? Distance of nth bright fringe from the central fringe is n lambda capital D by small d. Where is the first bright fringe is going to be formed? Tell me now, based on that relation. Based on that relation, what we have written, n lambda capital D by small d. Where is the first bright fringe? From the central fringe. Distance of first bright means y1b, I will write it. Where it is going to be formed? First bright means n equals to 1, you have to substitute. N equals to 0 means central bright. In that formula, yn is 0 means what? The central bright itself. You know, for constructive interference, n values will start from where? 0, 1, 2, 3 and so on. Means first bright fringe is going to be formed at n equals to 0. Sorry, not first, we should not call it as first bright. That is called central bright. Don't call the fringe which is formed at the center as first bright. That is central bright. On either side of central bright, you are going to have consecutive dark and bright fringes. The first bright fringe will be formed at a distance of y1b, I have written. See, this is y1b. What is the value of y1b here? Tell me now. If I substitute for n equals to 1 into this equation, what you will get? n1 in the sense y1 equals to lambda capital D by small d. That is the distance of first bright fringe from the central fringe. Means from central fringe, first bright is going to be formed at a distance of, first bright fringe will form at a distance of how much? Lambda capital D by small d. What is the distance of second bright fringe? Second bright fringe from the central fringe will be formed at a distance of, see, we need to substitute for n equals to 2, n equals to 3, n equals to 4 and so on for consecutive bright fringes. Second bright means n equals to 2, means 2 lambda capital D by small d. Distance from central fringe to bright fringe is how much? 2 lambda capital D by small d. Similarly, third bright will be formed where? Third bright will be formed at a distance of how much? 3 lambda capital D by small d. Similarly, fourth bright, 4 lambda capital D by small d. 5 lambda capital D by small d and so on. Nth bright, n lambda capital D by small d. So that's how we need to write for distance of nth bright fringe from the central fringe. Let it be. Now come back and we'll see what should be the value of if a destructive interference takes place here, for example. Destructive interference means which fringe is going to be formed there? Dark fringe will be formed. Destructive interference means dark fringe is going to be formed, right? What is the condition to form the dark fringe at that point? Nth dark fringe I want at point P means what should be the value of this? Y value we need to find out. What should be the value of Y? Y is what? Distance from central fringe to that point. At that point, if dark fringe is formed, what should be the distance? At what distance it is formed? We have to obtain in the same way. What we have to obtain? I'll say path difference, you got it as what? Delta x. Remember that formula, it is required. Again, I'll ask while writing the expression for fringe width, I'll define that. Let me mention even for dark fringe also. After that, I'll obtain the expression for fringe width. First, let me write down that also. So now, let that be nth dark fringe is going to be formed. What is going to be formed here now? Nth dark fringe is going to be formed at point P. If nth dark is going to be formed, so what should be the value of path difference for nth dark fringe? Nth dark in the sense, destructive interference should be formed. What is the value of path difference for the destructive interference means? What we have written? This is 2n minus 1 into lambda by 2 I told on the day, it can be 2n plus 1 or it can be 2n minus 1 also I told. 2n minus 1 if I write, n values will start from where I told? 1, 2, 3 and so on. 2n plus 1 if I say, it will be 0, 1, 2, 3 and so on. N values will be starting from 0, 1, 2, 3 and so on. Why it is so? I will explain now. So now first I will arrive at the equation, then I will write. So this is delta x equals to 2n minus 1 into lambda by 2. Okay. So finally, if you rewrite the relation, what you will get finally, you tell me? The distance of nth dark, I will write this one as ynd. Distance of nth dark fringe. Earlier you make it as ynb. Yn I have written, no, yn cap letter B you make. So that is the distance of nth bright, it will come. Here it is distance of nth dark, how much you will get if you solve for this equation now? This is 2n minus 1 into lambda capital D by 2D. See the formula here? 2n minus 1 into lambda capital D divided by 2D. This is the formula for what? Distance of nth dark fringe. Distance of what? Nth dark fringe from the central fringe. Means at which are all the points we are going to have dark fringe on the screen, or dark fringe on the screen in case of the interference pattern, means at all these distances from the central fringe for different values of n. Now, what should be the first dark fringe you are going to get? Let me substitute for n equals to 1 in that formula. So I hope you have written all this. I will rub this point over here. See, distance of nth dark if I want to mention. See, nth dark means I will say n equals to 1 here. Instead of 0, I have put n here. In that formula, if I put n equals to 0, it won't. 2n minus 1 lambda capital by 2d when we have written. I told n should be equals to what? Starting from 1 I have mentioned. That means the n value equals to 1 if I substitute what? Okay. So 2n minus 1. n equals to 1. If I substitute 2 minus 1, 1, lambda capital D by 2d will get here. If you substitute for n equals to 1, see, if you substitute for n equals to 1, then distance of first dark fringe y1d equals to n1, if I substitute, you will get 2n minus 1 is 1, that's why it is lambda capital D by 2d, lambda capital D by 2d. Distance of first bright, how much you got earlier when I have written? Distance of first bright means we got lambda capital D by small d we got. We have already written that. This is distance of first bright from the central fringe. First dark is how much? Lambda capital D by 2d means what? Half of this value. Lambda capital D by 2d means this value. By 2 means what? In between, exactly at the center line between the central fringe and the first bright fringe, we are going to have what? First dark fringe means at this point we are going to have what? First dark fringe. And then from central fringe, this length it will be equals to how much now? Lambda capital D by 2d. Next dark fringe where it is going to be formed? Second dark fringe means what? N equals to 2 you have to substitute. If you put n equals to 2, it will become what? 4 minus 1. 3 lambda capital D by 2d. Means 3 lambda capital D by 2d means what? That is 3 and half. 1.5 lambda d by 2d. This is lambda, first bright is at lambda d by d. Second bright is at 2 lambda d by d. Means it should be lying between first bright and second bright. Means this is second dark I can say. Similarly, third dark where it lies? Exactly at the center of second bright and third bright. What is going to lie? Third dark is going to lie. At what distance from the center? Distance of third dark means how much? Substitute for n equals to 3. 3 2s are 6. 6 minus 1, 5. 5 lambda capital D by 2D. So that is the distance of third dark fringe from the central fringe. Similarly, fourth dark fringe means what? In the same way, fourth dark fringe means 4 means 7 lambda capital D by 2D. Fifth dark fringe means 9 lambda capital D by 2D and so on. Now come back to the importance of this plus or minus I told you, right? If you put plus here, generally what happens, check it out. If I put 2n plus 1 into lambda capital D by 2D, you will get this is the value of what? Distance of nth dark you will get. If I put plus 1 here, n values will start from 0. Okay, first dark means n equals to 0 you have to take. Second dark means n equals to 1. Third dark means, why? Because n values are starting from 1 to 0, 1, 2, 3 and so on in this formula, no. n0 if I take, first dark you will get. n0 means you will get lambda capital D by 2D. That is why first dark is at n equals to 0. Second dark means n equals to 1. Confusion state will arise for you. Instead of that, if you take minus 1, you know, there is no variation for 1 and which dark it is, n and which dark. Nth dark is n. N value is nothing but what? N, if you substitute for n, you will get that dark fringe, nth dark, if you use this formula 2n minus 1. So that's why I asked you to remember this formula itself instead of 2n plus 1. There will be no confusion here, no. In 2n plus 1, if you make use, 11th dark means I should take 12 or 13, confusion will come there. So why that confusion? Simply, instead of making that, right, you can make that one as 2n minus 1. Where 10th dark means you substitute n equals to 10 directly here. Instead of thinking I need to substitute 9, I need to substitute, or 11 I need to substitute, that confusion, to avoid that confusion, right, better you remember this formula itself. 2n minus 1 into lambda capital D by 2D you have to remember with. So just a minute. Okay. So that is about the distance of nth dark fringe from the central fringe. What is the formula? 2n minus 1 into lambda capital D by 2D. Distance of nth bright fringe means n lambda capital D by small d. However it is, both are the same. So I hope you got these 2 points over there, the distances of nth dark and nth bright, and similarly what is the value of distance between one bright fringe and the other bright fringe also we have studied. What is the distance over there? Distance of nth bright fringe and the nth dark fringe difference also we have studied. How much? Lambda capital D by small d. So we will see the term what exactly it is. See, this is capital D, let it be. I will reuse this equation, or this graph is required for us. We will see. We will have all these. Now, see here, this is what the central fringe we have seen, this is what the central fringe. So, if you see, what is this? I will take this one as first bright, and what is this one? First dark, first bright and first dark. And next, and this is second dark, this will be second bright, and next third dark and third bright, and so on like that. This is third bright and so on. I will take here for your understanding. This is the first bright, no? This is second bright. So like that, and somewhere here I am going to take nth bright. This is central means I will take here, it is nth bright fringe. And what about this one? Before that, which bright fringe will be there? Before the value of n, what value you are going to get? N minus 1. That is why it is n minus 1th bright fringe I am going to consider. Let it be. This is nth bright and n minus 1th bright. I just want you to write the formulas for them even. What is the distance of n minus 1th bright fringe and what is the distance of nth bright fringe? Distance of yn and distance of yn minus 1. Let it be, or if you write even now itself better, yn it will be equals to n lambda capital D by small d, and yn minus 1 equals to what? Yn minus 1 equals to n minus 1 into lambda capital D by small d. So why I am telling those two means, here we are going to define one term called fringe width. So let me define that first and then we will see the expression. Fringe width, the distance between consecutive bright or consecutive dark, consecutive bright fringes. Consecutive means what? Between one first and second bright, between second and third bright, or between third and fourth, or between nth and n minus 1, or distance between consecutive dark fringes also. Consecutive dark fringes means what? First dark and second dark distance between them, or second dark and third dark, or third dark and fourth dark, or nth dark and n minus 1th dark fringe. So the distances are there between those fringes, right? Consecutive bright fringes or consecutive dark fringes. That itself we used to call it as fringe width, represented with the term beta. This beta expression for that is symbolically we are going to represent in most of the books. The same representation you are going to have. Symbolically we can represent fringe width what? Beta. That is distance between consecutive bright fringes or consecutive dark fringes. What do you call that as? Fringe width. Distance between consecutive bright fringes or consecutive dark fringes. Itself we used to call it as what? Fringe width. Distance between consecutive bright fringes. Consecutive bright fringes means you can't take distance between first bright and third bright as fringe width. They are not consecutive. Consecutive means one beside the other. After first, which bright will get? Second bright. Next, third, fourth, like that. You can't take distance from first bright to the 10th bright as fringe width, you cannot say, or you should not take that. Distance between consecutive meaning is what? Next to that bright fringe. Next to the bright fringe, which bright fringe is it? Should not take distance between first bright and first dark is not, distance between that first bright and dark will not give the fringe width. Keep it in mind. Distance between either consecutive bright or consecutive dark. I think it is enough for you so that you can understand what is that fringe width is. Now we need to write an expression for it. How to obtain an expression with the known terms. I told you, right, if it is nth bright, this will be n minus 1 bright. So what is the distance between these two? We used to call it as what? That's what I told you. What do you call that as? Fringe width. Distance between consecutive bright fringes. I have taken nth bright fringe here. Before that what you are having? N minus 1. First one is n minus 1. After that we will get finally what? Nth bright fringe. Distance between those two bright fringes is what? Fringe width. Means I need to subtract from this entire yn. See, from here to here is what? Yn, distance of nth, and distance of n minus 1th it is. If I subtract these two, right, what you are going to end up with? Fringe width you are going to get. That's what we have to derive. That's what this derivation is all about, what we are trying to get it out. So if you solve for it, so therefore fringe width, comma, beta it will be equals to yn minus 1. Yn is distance of nth bright from central fringe. Yn minus 1 is distance of n minus 1th bright fringe from central fringe. Okay, so that's what yn minus 1. If you substitute these values into this equation, what you will get? Implies beta equals to, yn means what we have written, n lambda capital D by small d minus, yn minus 1 means what? n minus 1 into lambda capital D by small d. Take lambda capital D by small d out here now. Lambda capital D by small d into, this is n minus n plus 1. N minus n, they will get cancelled. So finally we will end up with what? Implies beta equals to Hope it is visible. Beta equals to finally, or else right here, beta equals to lambda capital D by small d. Beta equals to what? Lambda capital D by small d. Distance of nth bright fringe, fringe width expression, it will be equals to what? Beta equals to lambda capital D divided by small d. I think it is visible, right? Or else I'll write here, beta equals to what? Fringe width expression is lambda capital D divided by small d. This is the expression for fringe width, what you have to remember with. Very important 5 mark question. Diagram to be considered is this. Simple, very simple. See, we have written for sin theta and tan theta values into this equation, into the known terms. We are writing this. We are extracting what is the path difference in terms of the given terms here. See, what are the given terms here? One is like distance from central fringe to this point P, which we have considered. This distance we are aware. Remember, distance from central fringe to the point P we are aware. Y. Capital D, distance of central, distance from source to the screen, or distance from slits to screen, right? Capital D it is. Distance between slits and the screen is capital letter D. Name this all terminology. When you are deriving the relation, initially you have to mention. So what you have to mention is, let us consider the Young's double slit apparatus, which consists of two monochromatic source of light which are taken from a cardboard, where which are two slits which is made up of, or two slits are made as two holes which are separated by a distance d. Now the slits of this cardboard are going to be acting as virtual sources which are coherent in nature. Okay. So, and then you have to mention, let us consider a screen which is at a distance of capital letter D from the slits. Let small letter d be the distance between the slits. Let lambda be the wavelength of light used. You can call it as sources, where lambda be the wavelength of light used, you can mention. So by taking all these, after that you have to consider, let P be a point on the screen which is at a distance of n from y from the central fringe. You have to mention in this way whenever you are going to go for a derivation. So this basic information is necessary. I can't keep writing all this. You have all those enough data or information in the form of a material you can see, or in the text, or by going through the derivation you can write in your own words also. Own words means whatever you want you can't, right? So what extent you can do it. I hope you know how you need to go for any derivation when you are going to take. Particularly preliminarily you have to define all the terminology what you are going to make use in the diagram, and then known equations or anything to be taken considered, right? You take for them and solve mathematically, obtain an equation, finally end up with the output or final result, whatever it is required, right? You can end up there. So this is the expression for what? Fringe width. See, here I have taken distance of nth bright and distance of n minus 1th bright. Instead of nth bright and n minus 1, I told you definition when we have written distance between consecutive bright fringes or consecutive dark fringes also. Consecutive dark fringes means what? Consecutive dark fringes means this will become nth dark. Let's say, I'll just assume this will become nth dark, and this will become what? N minus 1th dark. This will become n minus 1th dark. Obviously, fringe width is what? Yn is how much more? Here, Yn value is how much? Distance of nth dark is how much? 2n minus 1 into lambda capital D by 2d. This is the distance of nth dark. How about 2n minus 1 now? Sorry, distance of n minus 1. Distance of n minus 1th dark fringe from the central fringe. How to write? Just see. This is the distance of nth dark from the central fringe, from here to here, central to nth dark. N minus 1th dark means this length we want now, Yn minus 1. How to write Yn minus 1? Yn minus 1 equals to 2 into, in place of n what I need to write? If it is n, 2n minus 1 I can write. If it is n minus 1, in place of n minus 1 you go for n minus 1 substitution there. 2 into, see, or else it is 2 into n minus 1, 2 into, in place of n I have substituted for n minus 1, that's all. Rest of all the formula will remain the same. Just go for the substitution for n minus n there. 2 into n minus 1 minus 1 into lambda capital D by 2d. See this one, elaborate this, what you will get, this is 2n minus 2 minus 1, 2n minus 2 minus 1 into lambda capital D by 2d, this is lambda capital D by 2d, this will become what, minus 3 now. So that means 2n minus 3 into lambda capital D by 2d. Okay, na? So now distance between nth dark and distance between n minus 1th dark means what you will get, fringe width beta equals to, you know this, nth dark and distance between n minus 1th dark we are going to write. Nth dark and n minus 1th dark, nth dark and n minus 1th dark fringe. That means 2n minus 1 into lambda capital D by 2d minus of, what is the value of yn minus 1 we got? Minus of 2n minus 3 into lambda capital D by 2d. Elaborate this, what you will get now, I will take lambda capital D by 2d constant here into, remaining is 2n minus 1, 2n minus 1, minus of this value is what? Minus 2n, minus into minus plus 3. See, some small math, 2n lambda 2 by 2d I have taken common, remaining is 2n minus 1. Minus of this value is what? Minus 2n, minus into minus plus 3. If you see, plus 2n, minus 2n they will get cancelled. 3 minus 1, 2 means it will be lambda capital D by 2d into 2. See, 2 it will get cancelled. So what is the final value you are going to get? Lambda capital D by small d. Lambda capital D by small d. Even for bright fringes also, distance between two consecutive bright fringes, how much? Lambda capital D by small d. Distance between consecutive dark fringes, how much? Distance between two consecutive dark fringes, how much? Lambda capital D by small d. So this is the expression for fringe width. When they ask you, supposed to ask in the exam, right? No need of doing both of them. In between, I given even the distance of nth dark fringe formula also. Need not to include that in the derivation again. What are all you have to do for the derivation in this, what are all I have discussed, you know. No need of doing entire thing, what I have mentioned here. I will conclude, see here. First, this diagram, obtain the basic relations. What basic relations we have written? Equation for sin theta and equation for tan theta we have written. Both you have that. Go for the substitution for, in place of sin theta, you substitute what the tan theta value got. Tan theta is y by d. Sin theta is delta x by small d. In place of tan theta, substitute for sin theta value. Once if you substitute the value of sin theta into that, okay, you will end up with the expression for path difference delta x. You just say that which you are going to take. If you take it as nth dark or nth bright, it is your wish. You can consider that point P as nth, let nth bright is going to be formed at that point. You mention, let nth bright will be formed at point P on the screen. If it is nth bright, what is going to be, or like if it is nth bright, you know, what is the distance, what is the path difference for that at that particular point to form the nth bright fringe means n lambda capital D by small d only. 99% students will opt for bright only. Why? Because formula is very simple to remember, n lambda capital D by small d, distance of nth bright. You can also take this much calculation you will get if you take for dark. Instead of that, you can take that as nth bright. You know, yn it will be equals to n lambda capital D by formula you will get, n lambda capital D by small d formula you are going to get. After getting that, you write by the definition of fringe width, this fringe width definition in the beginning only you have to write. By the definition of fringe width, beta equals to yn minus yn minus 1. In terms of bright fringes, you substitute. Earlier we have written, no, what is yn and what is yn minus 1. Substitute into this equation and obtain the relation beta equals to lambda capital D by small d. So this is all about the expression for fringe width in terms of wavelength lambda. What is capital D? Distance between slits and the screen. Remember, after deriving in your classwork also, you elaborately write what is lambda here. Lambda is the wavelength of light used. Capital D is what? Distance between the slits and the screen. Small d is distance between the slits. So this is the data, or this is the points you have to remember regarding what? Expression for the fringe width. I hope all of you got the points related to the fringe width. So next we will see how the intensity pattern that is going to be formed on the screen here. How the intensity pattern that is going to be formed on the screen means intensity pattern in case of the interference. Let me write that. intensity, you see, intensity pattern that is formed on the screen means, remember here all the bright fringes are completely bright and all dark fringes are completely dark in case of interference. Means what is the maximum intensity we are going to have? For example, both the sources are identical, I will say. Identical means amplitude is same as well as intensities are going to be same, means A equals to B and I1 equals to I2. Let us say A equals to B equals to A, I1 equals to I2 equals to I0. Okay, na? What is the maximum resultant amplitude you are going to get? R maximum equals to how much? A minus B means what? 2A, double the value. R minimum you will get it as how much? R minimum is A minus B means A and B are equal, that is why it will be equals to what? 0. And maximum intensity means how much more? I maximum it will be equals to like in the previous session we have seen I maximum equals to what? 4I0. And what is the value of I minimum? I minimum you will get it as 0. I minimum you will get it as 0. Root I minus root I1 minus root I2 whole square you will get if for I minimum. I1 and I2 are equal, right? That is why I minimum value will be 0. What does this shows or what does this depicts? I maximum I am saying, when you are going to get the maxima in case of interference? Constructive interference. At constructive interference what is formed? Bright fringe. Means everywhere a bright fringe is formed, what will be the intensity? 4I0. And where the minima is going to be formed? Minima or destructive interference? Minima is going to be formed where? A destructive interference. Our destructive interference will take place. If the destructive interference where the point is going to take place, what is formed we are saying? What is going to be formed we are saying? Dark fringe is going to be formed we are saying. At dark fringe, at all the points on the dark fringes, what is the intensity? 0. At bright fringe, 4I0. All bright fringes, whether it is first bright, right? This is first bright, right? This is second bright, and this is third bright, and so on. And this first dark, second dark, third dark, and so on. Irrespective of which bright or which dark it is, at all the points on the bright fringes, means any bright fringe if you are going to take, all the intensities are going to be equal. How much it is? 4I0. This is a major conclusion we are going to make from interference phenomena. Not to showcase this interference phenomena, to explain the interference phenomena, in order to differentiate with what? Diffraction phenomena, this is a major difference you are going to take, whereas in case of diffraction it won't be like that. All maximas they supposed to not have the same equal intensity. Only the central bright will be maximum, and from as you move away from the central maxima, intensity goes on decreases in case of diffraction. But whereas in case of interference, it doesn't happen. If I draw the diagram for that, see not only on the upper side, on the lower side also same phenomena will take place. Whatever I have drawn, right? Here also this is first dark on the other side. What is formed here? First bright, and next second dark, and next second bright, third dark. Let me write brights over here. This is first bright, okay, and this is second dark, and this is second bright, third dark, and then third bright, and so on. On either side of this central bright, you are going to have consecutive bright and dark fringes, consecutive dark and bright fringes. That's what. If I say the intensity pattern, this is what the central, no? This is corresponding to the first dark, and this one corresponding to the first bright, and this is second dark, and this one is second bright, third dark, and third bright. On the other side also this is corresponding to what? First dark, and this one corresponding to first bright, second dark, second bright, third dark, third bright, and so on. If you observe the intensity, here it should be maximum, here it should be minimum, means you are going to get the intensity like this. This is first minimum, no? Like this. If you observe intensity, at the central bright intensity is maximum, As you move away from central, right, it becomes 0 here. How much is it exactly at this point? 0. Again at this point it is going to be maximum. Here it is 0 again, means what? So it is going to be like this. And how the intensity? At all bright fringes it will be same, means like this I can. This is second dark, no? This is third dark, right? Like this. And over here also this is second dark. And when I come across here, right, this is bright, you need to get here bright. And here it is dark, like this. And here it is bright, like this. And here it is dark, like this. And this is bright and dark. This is bright fringe, if I say, and dark, bright and dark, like this. See how the intensity is all. These are all what exactly? See, if you observe, this is the peaks you are going to get. Actually, if you plot like this on the horizontal axis, you are going to have on the time axis or whatever you call, with the distance, how the intensity is going to be vary. This is the central bright fringe, first dark fringe. Next bright fringe will be here, no? First bright, maximum intensity. This is the intensity I naught. You have taken on what? Y axis, and this is what? Distance from the central fringe, how it is going to be varied. As you move away from the central fringe, this distance you have taken on horizontal axis, and the intensity variation you have taken on y axis. So instead of plotting the graph like this, for corresponding bright and dark fringes, I have drawn here itself. Okay. So I hope you got this, how the intensity pattern you are going to have. So at this point, what is the intensity? 4I naught. That's the what. At this point, what is the intensity? 0. At this point, what it is? 4I naught. Here it is 0. Here it is 4I naught. Means all bright fringes are completely bright, purely bright they are going to be. And all dark fringes are what? Completely dark, or 0. Nothing is going to be seen in that region where dark fringe, wherever it is going to be formed, right? This is especially in case of interference. Dark fringes are completely dark. Means what? Completely dark means you can't find any kind of brightness in that region. You can't find any brightness in the sense what? Their intensity is 0 at that particular point. Got it? So likewise, you're going to have different bright and dark fringes on the screen on the either side of this central bright fringe, how it is going to be formed. See, this is all about the basic information related to interference. We have to discuss about some applications on the interference now. On this Young's double slit experiment, all the information or the data what we have discussed is about Young's apparatus, and the theoretical part are for the board's perspective, how much ever it is essential or required, we have studied all the information. Now applications, problems, how they are going to ask here, how they are going to ask the numericals on this particular concept of interference, and how we need to solve for them. What are all applications we have to study over there. So all the points one by one we will study, or we will discuss all those, or we will say, or in the coming session, right, I'll bring with some points to be learned with for competitive you can take or whatever it is. Soon after the completion of the entire interference, we will move on to diffraction. I told you, three headings we are going to study this particular chapter. One is interference, diffraction, polarization. Before going for these three, very basics we have studied what, from where this light has been originated, that is theories of light, what different people have their idea over the theories of light, what we have studied. A small extension for Huygens principle. Why? Because that brought light much into the, that has focused more over where majority of the properties of the light have been, or phenomena of the light have been studied by making use of what? Huygens wave theory. That's why we just had an extension for it, like proving for laws of reflection and refraction. So two equations we have proved for it, or two derivations, or however you call. So that laws we have proved, and then something related to the basics of interference, superposition, and all those we have studied, and we are almost at the end of this basic information related to what? Interference we have done. And applications on them we have to do with, and I will wind up this session for today. I hope you got some enough points over there. So important and so crucial the class it is. You please once again go through with all the points, make a note of all the points, and don't extract or don't think like only the virtual classes we got. Even if you are in front of us, the same information or the same data we are going to give. Okay, and even as an advantage you have now, like you can pause for it, you can recall, and you can If you have some doubt in that, you can throw a comment over there so that we can pick and we can answer for it. So please be conscious for all the online classes, what are all it is going to happen, and never neglect for all those things, what are all through the online, what are the sessions it is happening. So that's all for the day. We'll see the remaining things in the next session. Fine. Thank you.